Hello, Carson and Reese. We are doing 2-7 parallel lines and transversals. I had them do a little activity before we started, and so they're maybe a little bit ahead of where you are. So I'm going to kind of go through this a little bit faster than I would have normally, but they kind of know where some of this stuff is already. So here we go. Try to keep up. The keyword is tuna fish.
Ugh.
Keyword is tuna fish. Ugh. Tuna fish. All right, here we go. The first thing that I'm going to talk about is that who are my parallel lines? Billy and Carter. You guys were my parallel lines. You do not have to be parallel. This could be Billy, and this could be Carter laying down. You guys could, like, your feet could touch, or your heads could touch. Aww. Carter is here. Okay, Billy, Carter. All right. So you don't have to be parallel. You could be like weird, and this still like works. Okay, like this guy is still called the transversal. They will ask you for things like that. Transversal. Write that down. Transversal. So we still have those two lines, and we have a transversal going through them. What? This is on the front. On that diagram.
Oh.
I should say. Yep. Okay, so Billy, Carter, and our transversal. Okay, the interior is still in between Billy and Carter. It's still like that railroad track thing. Okay, and then the exterior is on the outside. So my interior angles, they have them listed there, are 3, 4, 5, and 6. These are my interior angles. They're the ones on the inside. That should make sense, right? Exterior angles are 1, 2, 7, and 8. Yeah?
Yep.
Okay, let's talk about alternate interior angles. Okay? Alternate means on opposite sides of this guy. Whoop. Opposite sides of this guy, but still inside. Okay? So 4, he is alternate interior with which one?
5.
I don't think that's, what is this? That looks like a 6 to me. Is that a 6? 4 and 6 are
Yeah.
alternate. They're on opposite sides.
Yeah.
Alternate means opposite. They're on opposite sides of that transversal, but they are still interior, okay? And then 3 would go with 5. Those are alternate. They're on opposite sides, but they are interior, right? Okay, let's talk about alternate exterior, okay? So which ones would be alternate exterior?
1 and 7 and 2 and 8.
1 and 7 are on opposite sides of the transversal, but they're on the outside of the lane. And then 2 and 8 would be alternate exterior, yeah? Okay, what does the word consecutive mean? Right here, consecutive.
Wait.
Consecutive interior.
What did you say 4 and 6 were?
4 and 6 were alternate interior. They haven't listed it off to the side over here. Right here. Alternate interior, alternate exterior. Okay. Consecutive, what does consecutive mean again? If it's not alternate, it's consecutive. Alternate means opposite sides. So like 3 and 5 are on opposite sides. Consecutive would be the same side, right? And consecutive interior means they have to be on the same side of the transversal, so same side of this line, but inside. So 3 and 6, right? 4 and 5. Okay, consecutive exterior, which they don't talk about over here. They don't talk about consecutive exterior. But consecutive exterior would be 2 and 7 and 1 and 8, yeah? Those guys? That's how that would work. Okay, and then corresponding angles are in the same corner, right? So angle 1, what corresponds to angle 1? Which one is this in the same corner as angle 1? Angle 5 is in like the northwest corner, right? You see that? Angle 2 corresponds to angle 6 there in the northeast corner, yeah? Angle 7 corresponds to angle 3, and 4 goes with 8, yeah? Do you see how that works? They're in the same, those are called corresponding. Okay, they're not, and notice that, here's how I can kind of remember this. Corresponding is the only ordered pair that doesn't have interior or exterior on the outside of it, right? Corresponding is the only one of those that does not have interior or exterior. Do you know why?
Because 1 is on
it's
the
on
inside.
both.
Right, 1 right here goes with 5. Well, 1 is exterior and 5 is interior. Corresponding has one of each, right? So that's why corresponding does not have an interior or exterior on the outside of it, right? Okay. All right. So most of your homework assignment looks like this, okay? Where they're saying these are my 2 things. What are their relationship? So let's go over here. My 2 lines that are parallel, or my Billy and my Carter, are this one and this one, right? This guy right here, what's he called again?
Transversal.
This is my transversal.
What did you say? Consecutive
No, I'm
angle is?
not.
Consecutive means on the same side of the transversal.
Like the inner angle.
That was
What
all
would be an
one.
example?
Transversal would be, or consecutive would be 7 and 6. Okay? All right, 1 and 5. Let's figure out what 1 and 5 are. 1 is here and 5 is here. Are they on the same side or opposite side? Opposite sides, so they are alternate exterior. See, you've already got it. Alternate exterior.
Oops, I accidentally dropped the
Okay,
ball.
abbreviate if you would like to. Alternate exterior, ALT-EXT. That will work just fine. Okay, 6 and 7 now instead. 6 and 7 are on the same side.
Consecutive interior.
Consecutive interior. Yep. Okay. Good. Next we have 2 and 4. 2 is here, 4 is here. Corresponding, because one's inside, one's outside. That just gives it away, right? Corresponding. Okay, and then 2 and 6. 2 is there, 6 is here. Alternate interior. Alternate interior. Perfect. Are we getting the hang of this? This isn't too bad, right? Yeah, not too bad. That's what the majority of your homework assignment looks like. Okay, they're going to talk about parallel lines and skew lines. Parallel lines are these two guys right here. You will know that they are parallel because they do this. Do you see those little arrows on those parallel lines? That's how you know that two lines are parallel. Okay, so from here on, we're going to be talking about parallel lines specifically. So Billy and Carter, you are parallel. You are not like crazy, wonky, weird where your heads are touching. Okay, like you're not going to intersect. You are going to be parallel from now on. All right, for the rest of this section, we're going to talk specifically about the lines being parallel. All right, skew lines. We had that word the other day. Skew lines are two lines that do not touch each other. So they're like out in 3D space. So like this one and this one looks like they might touch if this would continue on this way, but like this one is below this one. So this is what they look like. Those are not going to touch each other, but they're not parallel either, right? Okay, so those are lines that are skew. We're going to be talking specifically about parallel lines going forward, okay? So parallel lines, lines that don't touch, not skew lines, but skew lines don't touch either, okay? All right, go to, yeah, we're going to write some things down. Postulate 212 we're going to write down, and we're going to write down these 3. So we have 4 of them to write down. So everybody just flip with me to the top of the back side of your green sheet. We're going to start there, okay? And this is I think this one's a postulate. Postulate 212.
Yeah.
Postulate 212. So here we go. POST 212. This is the corresponding angles postulate. Corresponding angles postulate is what he is. Okay? All right, I'm going to go ahead and write the headings down for the other ones. So this one is Theorem 214, Theorem 215, and Theorem 216. I'll write these all down so then I can move over. Alternate interior angles theorem.
What was it? Something angles postulate?
Corresponding angles postulate, yep. For some reason they don't write the alternate exterior one next. They write consecutive. Consecutive interior angles. That bothers me that they separate the interior and the exterior, right? Like I think the interior one, or the alternate exterior one should go third. Whatever.
I cannot keep doing this.
Okay, there's your headings. Those are the 4 that we're writing down.
Why isn't there a
Okay, do we get those written down?
Not quite.
Okay, I'll give you a second. Okay.
Wait, what was the last one?
216. alternate exterior. Okay, I'm gonna draw my diagram, and I'm gonna draw the same diagram. I'm gonna use this diagram for
All of them?
all of them. So here's my two parallel lines, and here's my transversal going through. And I'm gonna call this angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, angle 8. That's my two parallel lines. And my transversal. My transversal kind of looks like he's not very straight, but whatever. He's being Tate, because Tate can't keep his head not turned and make a straight line. Whatever. Okay? Alright. I'm going to preface this with these theorems and postulates are only if the lines are parallel. Okay, so these theorems and postulates, what we're going through, these four only work if the lines are parallel. If our Billy and our Carter are parallel to each other. They only work if Billy and Carter are parallel. So if these two lines are not parallel, this does not apply. Okay? Good? So the lines have to be parallel in order for this to work. Okay? Alright, so corresponding angles. Let's talk about corresponding angles for just a second. Which angle corresponds to angle 1?
Angle 5.
Angle 5. Okay, now, those are corresponding angles. Yes, great. If these two lines are parallel, what will be true about angle 1 versus angle 5?
They're the same.
They will be the same measure. They will be congruent. They will be exactly the same value. Does that make sense? Okay, so I'm going to say corresponding angles, as long as the lines are parallel, corresponding angles are congruent. So angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. Angle 3 and angle 7. And angle 4 and angle 8. Those are all my groups that go together. Okay? Okay, good. Now the next one's alternate interior. Okay, so give me a set of alternate interior.
3 and 6.
3 and 6, or 4 and 5. Okay? Alright, so let's compare like 3 and 6 together, right? 3 versus 6. If those lines are parallel, what's true about 3 and 6? They're the same measure. Do you see that this is like an obtuse angle right here, and this is also an obtuse angle right here? Oh, hey, if the lines are parallel, that's the case.
Wait, so
Alternate interior, I'll write them down. Alternate interior angles are congruent. So that would be angle 3 would be congruent to angle 6, and angle 4 would be congruent to angle 5. Those are my sets of alternate interior angles. Alright, I'm going to skip down to the fourth one. Let's talk about the alternate exterior ones. So give me a set of alternate exterior.
2 and 7.
2 and 7. Okay, let's talk about 2 and 7. What's true about 2 and 7 if those lines are parallel?
The same.
They're the same. So alternate exterior, it's not just alternate interior. If they are alternate anything, alternate interior or alternate exterior, they will be the same measure. Alternate exterior angles are congruent. So that would be like angle 2 and angle 7. And angle 1 and angle 8, I believe.
Oh my gosh, 4 and 8 is for the consecutive interior.
No. 4 and 8?
4 and 6.
4 and 6 are consecutive interior. Okay? So 4 and 6 are consecutive interior. Let's compare those two.
Wait, let me
What's
guess,
true
let
about
me
4
guess.
versus 6?
They add up to be 180.
They are not the same value, right? They are not the same value, right? 4 and 6 will be supplementary, or they add up to be 180, because if 6 is this measure, right? 6 will be the same as 2. Do you see that? Because they're corresponding angles. Well, 2 and 4 live on this straight line right here. So they have to add up to be 180, right? So that is how the consecutive interior works, right? So consecutive interior, I'm going to say sum to 180. That means they add up to be 180 degrees, okay? That's all. So angle 4 plus angle 6 equals 180. And angle 3 plus angle 5 equals 180. I'm being lazy and forgetting my angle symbol, but whatever. It's fine. Okay? Good, good?
Not great.
Okay.
Okay.
Good? Okay, those are the 4 that we're going to write down. Let's go do some examples. Okay, let's do some examples. So example 2, it says, in the figure, the measure of angle 5 is 72. Okay, so this is the original one that it gives me, right? And these 2 lines are parallel. We know that because they are the arrows, right? Okay, so if that bottom number 5 is 72, what else do we know?
4 is 72.
4 is 72.
7
And
is 72.
7 is 72. And
2 is
2 is 72. Okay? All right, then 1, 3, 8, and 6 are all going to be the same. We know that, right? What will those all be? 108, because they add up to be 180, right? So literally, if I have 2 parallel lines and a transversal going between them, I literally will have 2 different angle measures out of all of the 8 angles. All of the 8 angles will either be a 72 or a 108. And that is all. Right? Does that make sense? That's very satisfying. All right. So angle 4 we said was, I can't remember which one was angle 4. Angle 4 was 72. Now, they want us to state the reason why. So angle 4 was this guy up here. What does he have in relationship to the original one that they gave me? What are those? Alternate exterior. Perfect. So just put that down. Alternate exterior.
Theorem 216.
You could put theorem 216, but I would rather you put alternate exterior because I'm not going to remember the theorem names or like the numbers, you know. Okay, angle 2 is what they want us to find next. Angle 2, I don't know which one angle 2 is.
72.
Is it this one right here? Is this angle 2?
Top
No,
one.
top one.
The top.
The one in pink and orange.
So it's the same thing.
Wait a second. Which one was angle 4 then?
Bottom left.
Oh, 4 was this one.
4 is corresponding.
Oh, crap. So 4 is corresponding. Wrong. We lie. Alternate exterior is angle 2. I just have them written over top and I can't see them. Angle 4, this guy and this guy are corresponding. Corresponding angles. So I got that. I just mapped them out wrong. Okay, good? Happy with that? Makes sense-ish?
Yeah.
Okay, let's go do some more. This is a proof of the alternate interior angles theorem. We're going to skip that. Let's go to example 3 on the back side.
Yay!
Example 3 on the back side. These 2 lines, they tell me in the paragraph that those 2 lines are parallel, and this is my transversal. They say that angle 1 is 118 degrees. 118 is what angle 1 is, and they say find the measure of angle 2.
118.
You only have 2 options. Your only 2 options are it's either also 118 or it is 62, which is the opposite of that, right? Like they add up to be 180, right? So is it 118 or 62?
118.
It's 118. Angle 2. Measure of angle 2 equals 118. Now, what does angle 1 and angle 2 have in relationship to each other?
Alternate interior.
They're alternate interior, and we know that alternate anything, interior or exterior, those values are the same. So 118 matches 118. Perfect. Okay? Good?
Great.
All right, example 4, and this is the last one. My 2 lines are parallel. How do I know those 2 lines are parallel, by the way?
The arrows.
The arrows, okay? Pay attention, because on your homework assignment, they'll have like 4 different lines going on here, and they'll have like a line going through here, and they'll like give you some information. Pay attention to which ones that are the parallel ones, okay? Because that will make a difference, all right? And it's just giving you more angles to do with, whatever. All right, so they say that the measure of angle 4 is 2x minus 17, and the measure of angle 1 is 85. Okay. So, Measure of angle 1 is 85. This is 85 degrees. Is 4 also going to be 85 degrees? No, it's the opposite of that, which is 95, right? If I subtract from 180, 180 minus 85 is 95. So I do the 2x minus 17 equals 95. You see how that works? 2x minus 17 equals 95, yeah? Okay, add the 17, which is like 2x equals 112, and divide by 2. 56, I believe.
Oh, we're only supposed to find x.
Yes, we're only supposed to find x, so we don't have to plug back in. Some of the ones on your homework assignment you will have to plug back in, but whatever. 56. Okay? All right, now, when they give you an A and B, the A stuff no longer applies. So don't try to like keep that information in there and like get bogged down with that. Okay, the A stuff is gone. The only thing that remains is those two lines are parallel, right? B says the measure of angle 3 is 4y plus 30, so this is angle 3. And the measure of angle 7 is 7y plus 6. We only have two options. They're either equal to each other or they add up together to be 180.
Equal to each other.
They are equal to each other. Those are alternate interior angles, right? Okay, so equal to each other, 4y plus 30 equals 7y plus 6. I'm going to subtract the 4y, and I'm going to subtract the 6 at the same time. So 24 equals 3y. Y equals 8. Yeah? Perfect. Okay? All right? The last thing is another theorem that we're not going to write down, but just listen to this. Okay? You ready for this? Ugh. These two lines are parallel, yeah? A and B are parallel. This thing says that if this line that line's a transversal between those two. If that line is perpendicular to this first line, it also has to be perpendicular to this one as long as they're parallel. That should make sense, right? If those two lines are parallel, those two, like if it's perpendicular to the top one, it has to be perpendicular to the bottom one. Okay? That is the perpendicular transversal theorem. Whatever. We're not going to write that one down. Okay? Good? All right. So, on the homework, odds on both sides.
Okay.
Okay? Odds and odds. Wherever my page is. I can't find my page. Odds and odds and odds and odds. Okay? Beautiful. Goodbye, Carson and Reese.
Oh, they were on.